Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, do let me know. Hello everyone, I hope that I'm live right now, guys. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please let me know. Good evening, everyone. Good evening. Good evening. Are you guys able to listen to me properly? Right? There's no issues with the audio or the video. No issues whatsoever, no problems. Okay, great. Awesome, guys. Awesome. Okay, so how are you guys? Is everybody fine? Is everybody great? How are you guys? Is everybody fine? Is everybody great, guys? Yes? Did you guys try to do a little bit practice about what we have learned in our yesterday's class? Did you guys try to do the practice about what we have learned in our yesterday's class, guys? Please let me know. See guys, one of my suggestions is in the class just focus upon what is being taught in the class itself. I've already provided you guys with the notes, right? So you don't have to worry about writing notes or something. Just listen to me properly in the class, try to understand what I'm teaching right over here. And after the class, just spend 15 minutes, just 15 minutes. That is not a very long period of time, right? Do not look at the video, do not look at the notes, try to recall what has been taught in the class and try to code it by yourself. That okay, today we were taught print statements. Okay, let me write a print statement in Python. Okay, next thing that we were taught was creating variables. Let me create my own variable right over here. Let me do something with the variable. We'll add a number to it, we'll delete my subtract number to it. Okay, naming a variable. Let me try to remember all the rules and regulations that were there with naming a variable itself. Okay, so I'm good with everything. I have revised everything. Now, what will happen in this particular case is that whatever you have learned in the class will become yours. Okay, will become yours. What I mean by that is you will always remember it throughout the entire future. This 15 minutes that you're spending is much more important than being in the class, guys. Actually, most of the students, when they learn something online, when they attend classes, this is where they lack. They think, okay, I've attended a class, I've sat in a class, I've done something within the class itself, I've learned something. No, you haven't. Actually, you just wasted your 60 to 90 minutes of your daily time. You could have invested that to watch the latest One Piece TV series. You could have invested that to watch and very good anime itself. Maybe you wanted to watch Dragon Ball Super. Maybe you wanted to watch some other anime like Demon Slayer, or you wanted to watch something like Irumakun Demon School. So you could have spent it on something that is much more enjoyable, right? Rather than listening to my shitty jokes. That is all that you have done in the class. Okay, that is my particular suggestion to you guys. If you really want to take back something from these sessions, just these 15 minutes of your time is all that you need to invest. That is the most important thing in this bootcamp. If you really want to learn something, see, certificates are not important. I'm being very frank with you guys. I've done certifications when I was actually working to get myself in a good company. When already had done two internships. I had done an internship in Reliance. I had done an internship in Geo. I was aiming to get into Google. I did a certification that costed me 1.5 lakh rupees, because in my college days as well, I used to do a little bit of freelancing. So whatever money I was able to earn from that in 2 years of my college, I actually spent the entire amount to do one certification. The cost of that certification was 75,000 rupees. And the worst part about that certification was it was not a course. It was actually the money that I had to give was for an exam. Like there's an exam run by Google itself. It costs you somewhere around $1,000 to give the exam just once. If you fail the exam, you have to pay once again that much amount of money to give the exam again. There is no course, there is no video lectures, nothing to study from. They give you a syllabus, you have to give the exam after that. I failed the first exam, I gave the second exam, I had the certificate, I got into the interviews at Google. Nobody even looked at my certificate. I was more than eager to show everybody that, oh, I've done this certificate and this is one of the best certificates in the entire world. Nobody even looked at my resume or the certificates that I had mentioned right over there. Nobody cared for it. The only thing that they cared was my knowledge, was my skill set, and my experience that I've done some internships beforehand as well. That's it. That was all that they care about. And when I went into Google, I worked there for 1.5 years. I actually met the person who took my interviews. I asked him point blank that I had so many certificates on my resume, I had such great certificates in my resume itself. Why did you guys not even see them? And their answer was pretty simple, because we don't care about that. I can give you 200 certificates directly. But what is the value of that certificate? The value is of your knowledge itself. When I ask you questions, if you are able to answer that, I know you have the knowledge. I don't even need to look at your certificate. If you are coming here, if you really want internships, if you really want placements, then focus upon the knowledge, guys. Are you guys able to understand what I'm trying to say? See, this is not something that will help me at all. What I'm trying to say to you guys, this is not at all something that is helping me at all. You giving 15 more minutes to just revise stuff, what is that of any help to me? Nothing. This is something I'm telling you guys to do, because this is something that if you are doing this, you guys are going to grow. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Okay, great. So let's start the today's session, guys. Again, today's session is going to be of 90 minutes long, 90. Be ready for that. Okay, and let's start with our today's class. I'll open up Collab once again, guys. So COLAB Collab, and I will open up your chat on my mobile phone so that I'm able to see that properly as well. So let me do that for you guys. So I've opened up the, where is the chat section? Shit, live chat. Okay, yeah, I got it. Okay, so your chat has been opened up on my phone. Recents, okay, data types and operators. I just opened one yesterday as well, October 3rd. I think so this is the one that was there. Let me just open that once again as well. And let me share my screen with you guys. Again, I forgot to do that. Nevertheless, we all know how to open up Google Colab and everything. So I don't think so that is something that I needed to show you guys. But still, okay, now everything's working fine according to me. We'll just connect to Google Colab so that everything works out properly for us. So yesterday we have learned about the print statements, we have learned about variables, we have learned about the rules and regulations related to naming a variable, we learned about multiple assignment operators, we learned about the conventions related to naming a variable as well. Now we're going to continue further from right over there, guys. Okay. Okay, so this is called, for example, think about it in such a way. Initially, you have taken up a house for rent in New York City, guys. Okay, you have taken up a house for rent in New York City. Now the rent is $1,700. When you approach the landlord first, the first month rent was $1,700. But the landlord came in the very next month and said to you, now I'm increasing your rent to $2,000 itself. Okay, so this is what is happening right over here. Initially, we have mentioned that the rent is $1,700. So in the variable rent, we are saving the value 1,700. Next, we are like changing that is rent is equals to $2,000 right now. What is happening right over here is that there was a box called as rent in which the original value was 1,700. But when you're changing that value to 2000, what you're eventually doing is you're picking out the coin that has the value of 1700, you're throwing it away. You are throwing that coin away and you're replacing it with $2,000. So this 1700 is actually lost to you right now. When you're changing the value in a particular variable, there is no way of going back to that same value. You can do this, you can write rent is equals to 1700, but you have no way to go back to the previous value itself. You can change it once again to whatever value that you want, but there's no way to go back. And this is what we call as overwriting the variable. The technical term for this is overwriting the variable. This is a very frequently used term, guys, inside of interviews and everything. So I want you guys to understand this. Again, guys, just to mention this, if you are writing present, sir, you are actually wasting your time right now. Focus upon the class instead of that. Those who have already visited our yesterday's class, I give a Google form inside of which I take up your attendance. The live chat is actually provided to you guys to put down your doubts and nothing else. So if you are writing present sir, those students who are writing present sir are already not going to get any certificates, because we are able to understand you are not paying attention in the class, you are busy writing present sir itself. So those students, I'm again reminding you guys once again, okay, and for the first time itself, writing present sir in the live chat means you are not going to get any certificates from DevTown even you have 100% attendance. Why? Because you are not paying attention to the class. Okay, you are not paying attention to the class. That means even if you are there in the class, you are not learning anything. We are very sure of it. So no, zero attendance, no particular certificates for you guys. So if you still want to write present sir, it is up to you guys. Okay, I'm not going to scold you guys or something, but due to you guys, the people who are actually interested in the class, who are here to learn, are not able to put up their doubts, and I'm not able to see the doubts inside of the live chat. Please don't write present sir in the live chat. I will just put that as a pinned comment as well. I'll put it down as a particular pinned comment as well. Okay, so if you are writing present sir, you are not going to get any certificates from DevTown sent. So those who are still writing it, please do remember, no certificates for you guys. Okay, so let's continue from right over there. This is called as overwriting the variable. Are you guys able to understand what is overwriting a variable? Please let me know. Are you guys able to understand what is overwriting a variable? Please let me know. Somebody asked, why are people still writing present sir? Because these are fools, these are idiots. They don't even understand English. Okay, they are here to learn Python and programming, and they want to become a programmer in the future, and they don't even understand English. A simple line of English that don't write present sir. Right? So just ignore these people, guys. They are here just to waste your time. Make sure if you meet them ever in the future physically, just punch them in their face itself. That is what I am going to do. Okay. So are you guys able to understand what is overwriting a variable? Basically, there was initially another value, rent is equal to 1700. We have changed that into rent is equal to 2000, and that's it. Okay, that's it, guys. That is what we are doing, going to do right now. Okay, the next thing that we are going to do is we are going to learn about another particular property inside of Python, that is how we can make code a little bit more shorter. For example, initially the rent was 1700. The landlord came to us, he increased the rent to 2000 rupees. Then we had an awesome crazy party in the house. Okay, we had an awesome crazy party in the house, guys, and due to that crazy party we actually broke a few of the stuff inside of the house. Okay, so some of the fixtures were there, some windows were broken. So the landlord came and saw it and has fined us $700 once again. That due to all these fixtures being broken, you have to pay $700 along with the rent this month. So for this month, our rent has increased by $700, guys. So we can reassign this value. So rent, we are writing it rent on the left hand side. We have already learned it about in our yesterday's class. We treat it as the box rent, that is the variable name rent. And on the right hand side, if rent is present, that means the value contained inside of rent. So the current value inside of the rent is $2000, right? So 2000 plus 700, that is 2700. So if we run this, we are able to get 2700 printed on our screen. Now the same thing, okay, the same thing if we are trying to do inside of Python, we can actually write it as rent plus is equals to 700. Both these sentences actually mean the exact same thing, guys. Okay, both these sentences, rent is equals to rent plus 700 and rent plus is equals to 700 are the absolute same, guys, are the absolute same. For example, if I still run it, I'm going to still see 2700 printed on our screen, guys. Are you guys able to see these? Please let me know. Are you guys able to see this and understand this? Please let me know, guys. Yes, and you can do this with other arithmetic operators as well. For example, rent is rent minus 700. So rent minus is equals to 700. You can do that. You want to do it with division, rent divided by 700, rent divided by equal to 700. You can do it with multiplication as well. Rent is equal to rent multiplied by 700. So rent multiplied by equal to 700. Again, it will give you the exact same results, guys. Okay. So again, you can do this as well inside of Python. The next thing that we are going to see right now is that data types. Now, data exists all around you. You see the text that somebody is writing, you see numbers that somebody is writing, you see if a person is telling the truth or the false at some particular point of time. So, data is all around you, guys. All around you, data is present. Now, please do remember this, guys. In every single programming language, this data has been categorized into various different types to make sure that the data is well organized. What they have done is, okay, all the number data will call it as this, all the particular text based data will call it as this. They have made different data types, and in every single programming language it is. So for example, I am learning Python right now, somebody else is learning another particular programming language. There is a programming language called as JavaScript, there's a programming language called as Pikachu, there's a programming language called as Brainfuck. So there are multiple different programming languages all across the globe. Now you need to understand something, that each and every programming language has its very own set of data types. I know many of you guys might have come after learning some other particular like programming language. Do not confuse between them. Okay, that I learned this particular programming language. Why are the data types different right over here? Because you are not learning the same programming language. Every single programming language has a different set of data types. They might be similar, they might not be similar as well. So you need to understand this in your brains, guys. Okay, so right over here, guys, the first particular data type that we are going to study about is integer, and the second data type that we are going to study about is floating point numbers, guys. Okay, so up till this point of time, whatever numbers that we have seen is mostly like 3, 2, 2700, 2000, 1700. These are all integers, guys. Just like in mathematics, you have integers, that basically means negative numbers, zero, as well as positive numbers. In a similar manner, inside of Python as well, you have integers. These are your negative, zero, and positive numbers itself. Now, floating point numbers or floats in short is basically your decimal values. Okay, your numbers negative, positive, or zero, but that should be a decimal number itself. Let us see that right over here, guys. For example, right now you are having 3 divided by 2, guys. Now 3 and 2 both are integers. 3 and 2 both are integers, guys. But when I divide them, as you are able to see, we are getting a number that is not quite an integer. This is a float or a floating point number, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. The difference between integers and floats, guys, are you guys able to understand that? Integers are your negative, positive, and zero whole numbers. Floats or floating point numbers are your decimal numbers right over there, guys. Okay, amazing. You guys are so smart, man. Great. Now, for example, a decimal point number 3.14 can be called a floating point number. So let us see this. Okay, let us see this practically itself. Let me go to Paint. So even though the number 42, okay, even though the number 42 is an integer, but the number 42.0 is a decimal number, guys. Okay, 42 is an integer, guys, but 42.0 will be a float. You need to understand that. And an integer can be converted into a float, and a float can be converted into an integer as well. Okay, an integer can be converted into a float, and a float can be converted into an integer. Let us see that. Okay, let us go back. So here there is a particular function inside of Python that is called as the type function, that basically helps us see what is the data type of a particular object. For example, if I want to check what is the data type of a variable called as A, okay, what is the data type of a particular variable called as A, guys, right over here, they can just write type of A, okay, type of A. This will give me the data type of the variable called as A, guys. Are you guys able to understand what is the use of this type of A? Are you guys able to understand what is the meaning of the term type of A, guys? Please let me know. Okay, so and then whatever data type of A is, I want to print that. Whatever the data type of A is, I just want to print that, guys. So for example, a is equals to 3. That is the first particular value. So a contains the value 3. B contains the value 2.5. So we know a is a particular integer, b is a particular float. So then when we run this, guys, as you're able to see, we're getting that type of a is basically integer and type of b is basically floating point number or float in short, guys. So this basically helps us figure out that. Now, if I want to convert an integer into a particular float, how can I do that? Okay, what will happen? Okay, let's see that. If I'm having a particular integer, guys, for example, it can be negative 42, it can be 3, it can be 2 itself. So all these are basically integers, right? All these are basically integers. If I want to convert them into floats, then what I need to do is just add 0.0 at the end, guys. I want to add 0.0 at the end. So minus 42.0, that's a float. 3.0, that is a float. Again, 2.0, that is a float. This is called as typecasting, guys. Type, casting, typecasting. Okay, this is called as typecasting, where you are converting one data type into another data type itself. So this is how you can convert integers to floats, and converting that is pretty simple. Just put parentheses around the number that you want to convert and then write float after that. FLOAT, float. This will convert this particular integer minus 42 into a float. You want to convert this into a float, put it inside of brackets, write FLOAT. You want to convert this into an float, just put it inside of brackets, write FLOAT, float, guys. Okay, this is called as typecasting, guys. If I go back to my code, okay, if I go back to my code and I do that right over here, for example, you are having a is equals to float 3. Okay, I'll just comment this out. A is equals to float 3, guys. I want to convert this integer 3 into a floating point number. So if I run this, as you're able to see, we are getting 3.0 printed out on our screen, guys. We're getting 3.0 printed out on our screen. Are you guys able to see this? Please let me know. Are you guys able to see this, guys? Please let me know. Yes? Okay. In a similar manner, if I want to convert floats into an integer, what will happen right over there? Let me go back to my paint. Everything. I'm having some floating point numbers. Let's assume 3.5, 3.2, 3.8. These are all floating point numbers, guys. I want to convert them into integers. What will happen? So there are two things. One is called as rounding of a number to the nearest integer or something like that, greater than that or smaller than that. And the second one is called as your truncating a number. Okay, truncating a number itself. There are two different categories of things that are present in mathematics. Now, again, this is not something that I should be teaching a particular college going student. This is a sixth standard concept, truncating and rounding off things. Okay, sixth standard mathematics is this. This is not related to programming. This is not related to anything else. Basic mathematics, truncating and rounding off a number. Here, when you are converting a particular float into an integer, you are actually truncating that number. You are not rounding it off. You are truncating that number. So what happens is whatever is present after the decimal point, no matter if it is big, small, I don't care about it. It will just get removed. It will just get deleted. All these three numbers will get converted into just 3. All with this will get converted into just 3, guys. Are you guys able to understand this? Please let me know. Truncating basically means whatever is present after the decimal point, no matter how big or small that number is, just remove it. Just remove it. That's it. As simple as that. Just remove it. Okay. So as you're able to see, all these three numbers will actually become just 3. Okay. No matter if it is 3.8, 3.2 or 3.5, just 3 at the very end. So let's go back and let us put this up. So 28.9 will become 28, guys. If I run this, as you're able to see, 28.9 becomes 28. Okay, now a main thing, guys. Everybody has taken up the attendance yesterday, if I'm not wrong. Today there are going to be two attendances in the class because the class is 90 minutes long. We have a long period of time. There are going to be two attendances in today's class. If you miss out any one of the attendances, you're going to get zero attendance for today's class. Are you guys able to understand this? If you miss, I'm going to take two attendances in today's class. Okay, 2.A and 2.B. If you and that can be taken up anywhere in the middle of the class itself. You will just get 5 minutes to fill up your attendance. If the link is not working for you, you have to refresh or reload the link to make it work. I've taken up more than hundreds and 200s of boot camps. So don't tell me the time is less, time is more. Nothing like that. Time is more than sufficient for everybody right over there. Okay, if you miss any one of the attendance in today's class, your today's attendance is zero. So if you think that, okay, I will fill up the first attendance, I'll leave the class, I'll come back later on, you might have already missed the second attendance as well. So for those students who are here, please make sure of one thing. If you miss any of the attendances in today's class, two attendance are going to be there. You're going to get zero attendance for today's class. Zero. Any one is missed, zero attendance. Okay. Are you guys able to understand this? Please let me know. And you're going to get just 5 minutes to fill up your attendance, which is more than sufficient. Every single time I take up the attendance for in every single of my boot camps, those students who are not paying attention in the class are the only ones who actually are not able to fill up the attendance. Everybody else is able to do that. Okay, great. Let's continue with the class right over there. The next thing, okay, this is a very, very, very important thing, guys, that we are going to talk about right now. So try to understand this. Before continuing further, let us take up the first attendance right now, and then we'll continue further itself to point A on the send link. So this is the first attendance of today's class, guys. Again, I can take up the second attendance just after 5 minutes as well. I don't really care about that. Please start filling up the attendance. The attendance link will be closed exactly at 8:47, guys. The attendance link will be closed exactly at 8:47. Okay. The attendance link will be closed exactly at 8:47, guys. If you are facing a particular traffic error or the attendance link is not opening for you, just change the link and open refresh or reload the attendance link. Those who have been there in our previous class, they know how to fill up the attendance. Those who are not there in our previous class, they will not know how to fill up the attendance. There are multiple links right over there. If you're not able to fill up, see, the attendance is going to be taken up by using this particular, you have to fill up this Google form to get the attendance for today's class. If you're not able to fill that up, guys, you're not going to get the attendance. At exactly 8:47, the attendance will be closed. We had 2,400 people live with us, and you will easily be able to see that the number of people have already filled up their attendance. Those who are joining us late or those who are not paying attention in the class are the only ones who miss out on their attendance. Okay, so please start filling up your attendance right now, guys. At exactly 8:47, the attendance link will be closed. So if we input 3 by 2, which converts into 1.5, and then we int 1.5, it becomes 1. But we use 3 by 2. Okay. So because you are converting it, you are typecasting it, right? When you are doing 3 by 2, even though that both are integers, division is one of the operations which will give you always a floating point number. No matter if you are dividing two integers, you are dividing two decimal values, you're dividing to one float and one integer, you will always get a floating point number as an answer. And then you are changing it into an integer. That is the reason why you're removing everything after the decimal point and you're getting one as your answer itself. Okay. Yes, try it out. You are having the Google Colab access, right? Try it out. See what is the result. Guys, like I've already said, the attendance will be closed exactly at 8:47, guys. Please do make sure that you are able to fill up your attendance. As you are already able to see, 1,252 people have already filled up their attendance, guys. Only a few more are remaining. If you're getting a traffic error, just refresh or reload the attendance, guys. If you're getting a traffic error, refresh or reload the attendance. I've already told you guys yesterday as well. I don't think so I need to repeat it every single day. Okay, so 1,800 students have already filled up their attendance, guys, at exactly 8:42, 8:47. The attendance thing will be closed. We're just waiting for 2 more minutes, guys, so that nobody's missing out on the class. Okay. Okay, somebody's saying to repeat this particular part. So what you're doing right over here is basically type conversion. Okay, you are converting one data type into another data type itself. Something was stored inside of a water bottle that is rectangular in nature. You're converting that into a cylindrical water shape itself, and basically changing the data type of that object. So if you want to change an integer into a float, doing that is just by adding 0.0 at the end. That is how you convert it into a float. As you're able to see, 3 gets converted into 3.0. In a similar manner, 28.9 gets converted into 28. That is, you are changing a float into an integer, guys. So if you are changing a float into an integer, whatever is present after the decimal point just gets removed right over there, guys. One more thing I wanted to be very clear with, I think so I have not told you guys properly. For example, you are having print 3 divided by 2, guys. Okay, we are having print 3 divided by 2. If you're getting a traffic error, that is not even possible right now. But if you're getting a traffic error, refresh or reload the attendance. I've already told it yesterday as well. I'm telling it right now. Refresh or reload the attendance if you're getting a traffic error. Okay. Like I said, guys, 3 divided by 2, both of them are integers. Please do remember, even if it is 4 divided by 2, guys, can you guys let me know? If it is 4 divided by 2, what will be the answer, guys? If it is 4 divided by 2, what will be the answer? I'm going to close the attendance, guys. As you are able to see, 2,400 people were live with us. 2,500 people have been able to fill up the attendance. So as you're able to see, if you're present in the class, if you're focused in the class, you're not doing matargasti in the class, then you're going to get your attendance. Otherwise, you're not. It's as simple as that, guys. Are you guys able to understand it? Those who are late in today's class, this is your final warning. As you are able to see, if you are late in the class, you're not paying attention in the class, you're not focused in the class, you're going to miss out on your attendance. 2,460 people were live with us, and 2,500 people have been able to fill up their attendance. As simple as that. This is the live proof of if you are not present in the class properly, if you're not paying attention in the class, you're going to just miss out on your attendance. And I really don't care about how many people are attending the class. Even if it's one person who is interested to study, I'm more than willing to pay attention to him. If it is 2 people, if it is 2,000 people, I'm more than happy to pay them attention. I'm more than happy to help them out as well. If you are not present in the class, some people asking, where is the link? Great people, great personalities, amazing peoples. Okay, good. Okay, so let's continue with the class, guys. So like I said, the question is very simple. If I do 4 divided by 2, what should be the answer? Somebody saying 2, somebody saying 2.0. Like I've already said, no matter what numbers you are dividing, even if it is integers, even if it is floating point numbers, it is combination of integers and floating point numbers, the answer is always going to be floats. No matter what type of division you are performing, the answer is always going to be floating point number, guys. Are you guys able to understand this? Please let me know. The answer is always going to be floating point number. Are you guys able to understand this? So if I'm dividing this right over here, as you're able to see, the answer is 2.0. The answer is 2.0. Nothing more, nothing less than that. There is another type of division, guys, that exists, that is called as an integral division. Okay, or integer based division, guys. This is also called as float division or floating point division itself. That is the normal division, wherein you are taking up any type of two numbers, the answer is always going to be floats. But sometimes you don't want that. Sometimes you want your answer to be an integer. For that, you are having another operator inside of Python. These are called as operators. Okay, plus, minus, division, multiplication, exponentiation, all are operators. One more operator that is present inside of Python is called your integral division, in which when you are dividing two numbers, the answer is always going to be an integer. If you're dividing two numbers, the answer is always going to be an integer, guys. For example, 4 And the operator that is for integral division is 2 forward slashes. If you are writing 2 forward slashes, that means you are trying to perform an integral division itself, guys. It is integer based division. So if I run this, as you're able to see, we are getting the answer as an integer, that is 2. What about 3 divided by 2? Okay, 3 integral division by 2, guys. If I do that, the answer is 1. It automatically converts it into an integer. Whatever your final answer was, it automatically converts that into an integer, guys. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? What is an integral division? In which the answer is always going to be an integer. Your usual normal division, guys, the answer is always going to be a float. The answer is always going to be a floating point number. Okay, great, amazing. Now we are going to have a very important thing for interview preparation. This is an interview based questions on Python. Okay. The reason why I'm telling you guys this question is because you are not going to find it in any course. You're not going to find it in any particular place. This is a very, like, even for my first interview, I think so, it was in DE Shaw. My first interview for placement was in DE Shaw. In that interview, this question was actually asked to me, and I had no answer for that. Even I didn't knew what is the answer to this question. And this is a very common question in every single Python interview. For good companies, this is a very important question, guys. And you are not going to find it in any course or anywhere else. You actually need to practice Python to a very good extent, as well as read a lot of books to get this answer. That is what I did after my interview. So I'm going to tell you guys this question. The question is very simple. Why are floats, okay, the question is very simple, why are floats said to be an approximation to the number they represent? This is the question, guys. Why are floats an approximation to the number they represent? This is the question, guys. Very simple, very easy question. Okay, I'm going to tell you the example. I'm going to tell you the logic behind it. I'm going to give you some ideas behind it on how to answer the question properly, and some additional questions that are going to be there. But these are very important questions. Why are float said to be representations, or an approximation to the number they represent? Okay, many of you guys are asking about the attendance. So let me be very frank and very clear with you guys. You guys were not present in the class. You guys were not paying attention in the class. Do not say otherwise, that I was present, I was not able to get the link. It is just impossible. Yesterday as well, I told you guys how the link will be provided to you guys. Today as well, I provided you guys the link in this exact same way. You guys, because of your lack of attention to the class, or lack of incentive to actually be present in the class, have already lost the attendance in today's class. Okay, I've already lost the attendance in today's class. The most that I can do for you guys is give you a final warning. Usually 1 day of attendance missing, we still give you guys the certificates, because we are able to understand that because of your foolishness, or because of your some important task that you had to do between the class, you were not able to pay attention to the class. One attendance if you are missing, we still give you guys the certificates. So this is, consider this as a final warning. If you are not present on time in the class, you are not present and you are not focusing inside of the class, you are going to miss out on your attendance. So please do not tell me, and I'm not going to open up any attendance. You have already lost it. Your one attendance is already gone. I can't do anything about it right now. What you can do right now is pay attention to the class. Make sure you are attending the class every single day on time and paying attention and learning something right over here. Certificates are not for everybody. Certificates are only for people who are actually coming to the class and paying attention and learning something. Not for people who are just opening a YouTube video and sitting like this. Not for them. The certificates are not for them. If you want the certificates, pay attention to the class. That's all that I can say about it. Now, please focus upon the class. Do not ask for attendance once again, because you have already lost it. Okay. Okay. Let's continue with the class right now. Like I said, floats are an approximation to the number they represent. Let us first try to understand what does this particular statement actually mean. Okay. The statement basically means a very simple thing, that when I write 4.2, inside of Python, it is not exactly equal to 4.2. It is actually a little bit greater than 4.2. This is the meaning. Now I'm trying to make you guys understand what is the meaning of this sentence. Floats are an approximation to the number they represent. I'm trying to make you understand the meaning about it. that actually 4.2 is represented inside of Python as 4.2 dot dot 0, 0, 0, 1, 2, 3, something like this. This is what it actually stores, what Python sees. When you're writing 4.2, this is what Python actually sees, guys. Okay, now this 1.2 is not exact. I'm just giving an example right over here, but they are an approximation. They are a little bit greater than the number they represent. A little bit. Okay, now let us try to prove this, that this is actually the case, that this actually happens inside of Python. Okay, let us try to prove that. Let us go back inside of our code, guys. Here I mentioned the code. Here I have added 0.23 30 times, guys. Okay. Here I have added 0.23 30 times. What, according to us from the basic mathematics that we understand, 0.23 added 30 times should be equal to 6.9, right? 0.23 added 30 times should be equal to 6.9 according to basic mathematics. I don't know anything about Python programming. I know maths, and according to my mathematics that I've learned since my childhood, 0.23 added 30 times should be equal to 6.9. Am I right or wrong, guys? Please let me know. Yes, but here what I'm checking is 0.23 added 30 times. Is it equal to 6.9 or not? Is it? So this double equal to sign basically checks if the left hand side is equal to the right hand side or not. If it is right, then we are going to get true. If it is wrong, then we are going to get false. Okay, it is basically checking whether the value present on the left hand side is equal to the value present on the right hand side or not, guys. So if I am running this particular statement, as you're able to see right over here, we're getting false as the answer. That 0.23 added 30 times is not equal to 6.9. Let us see what it is equal to. We'll remove this. We'll just print what is the value of 0.23 added 30 times, guys. The value that it is there is 6.90000000006. This is the value of 0.23 added 30 times, a little bit greater than 6.9. So we have proved the hypothesis correct. We have proved the hypothesis that floats are an approximation to the number they represent. They are not exactly equal to the number they represent, guys. Now we need to understand why is that the case. Why are floats an approximation to the number they represent? Why are they not like exactly equal to 0.23? Why are they a little bit greater than 0.23? Let's try to understand this, guys. Okay, so let us go back to our drawing board. Let's have two particular numbers. The first particular number is 2.3 and the second particular number is 2.3. We are multiplying these both numbers. What is the answer, guys? What is the answer? 0.23 multiplied by 0.23. What is the answer, guys? Can somebody let me know? 0.23 multiplied by 0.23, guys. What should be the answer? Somebody is saying 5.29. Okay. So the answer is 5.29 according to you guys. According to the mathematics that we know, the answer is 5.29, guys. 5.29. Being very frank with you guys, if this number is exactly equal to 2.3, if this number is also exactly equal to 2.3, where the fuck are you getting this particular value from? If you are saying that there are two chairs, right? You are saying that this is one chair. This is the first chair. This is the second chair. Okay, you are having two chairs. And here, both these numbers, this number is having one chair, this number is having one chair. Then where are these two chairs coming from? Your Python, basically your computers work on the basis of something called as memory. Your Python basically works on something called as memory. Now, in the first particular number that you're having just one decimal point that you can store up to, 1D, one decimal point. That is the maximum that you can store up to. The second particular number as well, you can store up to just one decimal point itself. You can store just up to one decimal point. Then your answer as well is going to be up to one decimal point. Your answer as well is going to be up till one decimal point. Your final answer will just be 5.2, not 5.29, because you don't have a second decimal point. Are you guys able to understand this? Please let me know. Gitesh, we are going to come there step by step. Let's first try to understand the answer. Gitesh, step by step. We'll progress. I know. I'm going to come there. If you see my answer, it already includes that. Okay. So if your first number has one decimal point that can store a maximum of 2, your second number as well can store up to maximum one decimal point, then your answer also can store up to just one decimal point itself. This is the reason why floats are stored as an approximation to the number they represent. So your 2.3 will be stored as 2.3000000000000123. Your next 2.3 will be stored as 0.00000000000123. And then when you are multiplying both the numbers, you're getting the answer of 5.2900000000 something at the very end. This is the reason why you are actually storing the number floats as an approximation to the number they represent to maintain something called as precision. This concept is called as precision, guys. How precise can your answer be? Up till how many decimal points can you give me a precise answer? That is what precision is. Okay. So if you're not doing this, you're not going to get a precise answer. You're going to do 5.2. That is very off the track from the answer that you needed. Now this 0.0000123 at the very end is a very small value that is there, but you are able to get a precise answer. You are able to get a precise answer right over there, guys. Are you guys able to understand this? See, please don't ask me to repeat anything. If you want me to repeat something, this is a YouTube video. You can actually scroll it back and listen to it once again. Tell me exactly what you didn't understand. That I didn't understand this. So I will be able to explain that in a new way. Please try to understand it. Repeating something, this is a YouTube video. Scroll it back, listen to it once again. Done. I've already repeated myself. But if you are not able to understand something, write exactly what you were not able to understand. Then I'm able to explain you guys in a new sense. Okay. Great, awesome. That is the reason why we store floats as an approximation to the number they represent. That we are able to get a precise answer. That up till 3 decimal points, up till 5 decimal points, up till 10 decimal points, we are able to get a correct answer itself. Now, please don't take that 1, 2, 3 on your hearts. That okay, every time this is going to be 1, 2, 3 itself. That is just an example that I've given you guys. Okay, exactly. Even I don't know what is there at the end. This is just an example that I've given you guys according to my mind. Inside of Python, I don't know what is there at the end. Okay. If you have not understood it, just rewind the video, listen to it once again. Most likely you have not paid attention to it properly. Okay. And I'm not going to explain the entire thing in a new way. There's no possibility of that. So I didn't understand what decides the end digit. So that is basically Python. Python and your computer. What architecture is your computer, how many bits that it can store. That is what decides the end integers. You don't need to understand what is there at the end. You just need to understand that up till a long trail of zeros, we are storing the number as a float so that we are able to increase the precision. You don't need to understand this, guys. This is not something that you need to understand what is the digit right over there. You just need to understand the concept right over here. Okay. Are you guys able to understand this? Please let me know. Okay, let's go back to our question, guys. Let's go back to our question right over there. Let's give it a googly. Okay, what a particular person said right over there. Let's give it a googly right over here, guys. What do you think will be the answer of this? Multiplied by 30. What do you think will be the answer of this, guys? That, okay, print 0.23 multiplied by 30. Can somebody let me know? So it should be the same answer according to us. We just learned right now that okay, 0.23 is stored as a like a long trails of zeros and then a particular value. So like it's a representation, it's an approximation to the number they represent. We should get the exact same value. Let us see what the answer is. Actually, it will not get the same value, guys. If we run this, we are going to get 6.9. I'm going to get exactly 6.9. There's a reason behind it. Now, all your different type of questions will be answered. First, please try to understand this. Floats are an approximation to the number they represent. This line is true. But what will be your output will be solely based upon what type of computer you are using. For every single computer, the architecture of the computer is different. Maybe you are using a Windows laptop, maybe you are using an Apple laptop, maybe the OS is different, maybe the working software is different, maybe you're using an Intel CPU, somebody is using an AMD CPU itself, somebody is using a Pentium CPU. For every single architecture, the answer is going to be different for you guys. So what is going to be the answer? Nobody can be very sure of that. What somebody can be sure of is that floats are an approximation to the number they represent. That is something that you can be sure of 100% of the time. What the actual answer is going to be there is totally dependent upon your system. What computer, what architecture, what OS you are using. Because that is what stores how numbers are going to be stored at the backend. Okay, how memory is going to be allocated. Right over here, let us try to understand what is happening here as well. Python is not a dummy. Okay, Python is not an idiot. Python is a little bit intelligent in its own way. In its own way. Okay, because please try to understand that the people who have created Python were geniuses. So-called geniuses they were. Now, these geniuses always try to optimize stuff. They knew that Python is stored as a, but in Python, floats are stored as an approximation to the number they represent. They created that to make sure you're getting a much more precise answer. But there are some optimizations that you can do right over there. What is addition, guys? Please tell me. What is addition? How can you, sorry, what is multiplication? How can you explain multiplication in terms of addition, guys? Can somebody let me know? How can you explain multiplication in the sense of addition, guys? Can somebody let me know? Repeated addition of the same number. Please, this is the total definition. Repeated addition of the same number. Now, what is happening when you're adding 0.2330 times? Let us see this. Let's assume I am Python. I'm seeing this particular question in front of me. I will put up blinds. I can only see two numbers at a time. Python can only see two numbers at a time. So I'm putting up a blind right over here. I see the first number and the second number 0.23 plus 0.23. Okay, 0.23 plus 0.23 is equal to 0.46. Okay, now I'm taking up this 0.46 and moving a little bit further. Now I'm adding 0.46 plus 0.23. These numbers are not the same. No optimization is possible. Every single time I'm moving further, I'm adding a new number with 0.23. So I don't know if all the numbers that I'm adding is 0.23 or not. Python is not able to understand that. It is not that smart as well. So what it does it, whatever is present at the end of the decimal points, that 0.2300000123, it adds that as well. Every single time moving further, it will continuously add that as well. So every time that numbers gets bigger and bigger and bigger to the point where Python is actually not able to ignore it. To the point where Python is not able to ignore it, and hence you get this 0.0006 at the very end. But what happens when you are multiplying stuff? What happens when you are multiplying stuff itself? 0.23 multiplied by 30. Python knows that it is multiplication, and multiplication is just repeated addition. So I'm going to add the same number 30 times again and again and again. So what it does it basically adds all the numbers, and then so it will do 0.23 plus 0.23, and whatever is present after that, it just removes it. It refreshes it. whatever is present at the very end, it just refreshes that because it is able to understand something. Now I'm adding the exact same number again and again and again. So these decimal points are there after 0.23 does not matter to me. Does not matter to me. So I will add 0.2300000123. I'll again add 0.2300000123. I'll get 0.4600000246. I will just refresh that. I will refresh all the zeros and put a new number, and then I'll again do the addition right over there. Because it is multiplication, there's a fixed definition of that. Hence, Python is able to do this optimization right over here, due to which you are able to get the answer exactly to be 6.9. What about adding 0.23 less number of times? 0.23 plus 0.23 plus 0.23. If I add 0.23 just 3 times, you are able to see we are still getting 6.9 as the answer. Okay. Let us add it 2 times itself. On some computers, it might work with 3 times. As you're able to see, we are getting just 0.46 as the answer. We are not getting 0.460000 something at the very end. Why is that the case? Can somebody let me know? Think about it. Think about it. What optimization is Python able to do on the small number addition itself? That we are not going to get 0.46 right over there. Think about it in such a way, guys. 0.23 added 2.2 times, we are able to get 0.46, not 0.460000 something at the very end. Why? Because this very long 0000, it's very small, and Python can ignore that right over here. The value 0.0000000236 or something like that at the very end is very small, and hence Python is able to ignore that. As you are adding more and more values right over here, as you're adding more and more values right over here, the number becomes larger to such an extent that Python is no longer able to ignore it. The number becomes larger so that Python is not able to ignore it right over there. Are you guys able to see this? The more numbers that I'm adding, the value becomes larger in such a case that Python is no longer able to ignore it, and hence we are getting this value. Are you guys able to understand this? Please let me know. So this is the explanation that you have to give to the interviewer as well. The interviewer will definitely ask you for some examples, and hence I've provided you with some examples as well. And so the answer is going to be to improve the precision of calculations. That is the answer. That why inside of Python floats are stored as an approximation to the number they represent to improve the precision of the answers. That is, up till how many decimal points can I get a correct answer. Due to that clear reason, we are storing floats as an approximation to the number they represent. Give me some examples. These are the examples. And then they will ask, what about multiplication? When I'm doing multiplication, why am I getting the same answer? Why I'm not getting these zeros at the very end? You can explain it in such a way itself. Okay, this is a very, very, very important concept, guys. That is the reason why I'm teaching you guys so early on, because in most of the places you are not able to see the correct explanation of this. Okay, let us move further with that, guys. We'll move further with the next data type, that is Boolean data type, guys. We're going to also study about the logical and comparison operators as well. A very simple topic. Most of you guys must have studied this inside of physics. Do you guys remember logic gates? Do you guys remember logic gates, guys? Please let me know. Do you guys remember logic gates? Please let me know. Do you guys remember logic gates? Please let me know, guys. Yes, it's the exact same thing. The exact same thing. Zeros and ones, we learned about it. Inside of Python, we call it as false and true values. And you have the comparison operators, the logical operators in the exact same way. Let us look at that from the scratch. Okay. Bool or Boolean. Okay, so bool is basically the short form of Boolean data type, and it has just two values, that is true and false. Okay. For example, you can create that. Always please remember, Python is a case sensitive language. For Python, a capital T and a small t are two separate things. So to create a true value, you have to write it as capital TRUE. If you're writing small TRUE, it is not going to count. It is not going to count, guys. And similar to that, capital FALSE, that is how you create a false value. You can store it as well, just like normal variables and values inside of it. We'll move back to the next little thing. This is what we call as comparison operators. You are having the arithmetic operators, right? Plus, minus, division, multiplication, integral division, exponentiation. These are called as comparison. These are called as arithmetic operators. They are having the comparison operators. As the name suggests, you compare two values. You compare two values right over there. For example, 3 is greater than 1. Okay. Is 3 greater than 1, guys? Please let me know. Is 3 greater than 1, guys? Please let me know. We're comparing two values, guys. Is 3 greater than 1? Yes. So you're going to get a value that is true. Okay. Similar to that, there are other comparison operators. For example, 3 is greater than equal to 1. Okay, this is wherein it checks whether 3 is greater than or equal to 1. Then you're having the equal to symbol where you basically check is 3 equal to 1 or not. You want to see if LHS is equal to RHS. We have already seen that. That is what you're checking right over here. You can have 3 is less than 1. Is 3 less than 1? So no, 3 is not less than 1. You will get a false value right over here. Is 3 less than or equal to 1? So no, it is not less than or equal to 1. You can even check if 3 is not equal to 1. This is where you're getting 3 is not equal to 1, guys. Yes, 3 is not equal to 1. Of course, you're going to get a true value, right? So these are called as comparison operators, where you compare two values to understand what is the comparison between them. And based on that, you get a Boolean answer. You get a Boolean answer at the very end, guys. In a simple manner, guys, let us move further. You are having the logical operators. The logical operators are your and, or, not operators that existed inside of your logic gates as well. Why logical? Because there is a logic behind it. Is the left hand side true and the right hand side true? Only then the answer is going to be true for the and gate, right? In a simpler manner, you are having these logical operators as well. For example, let's assume rent is $1,200. Okay, rent is $1,200, guys. Is affordable equal to rent greater than 1,000? Is rent greater than 1,000? And rent is less than 2,000? Then only in that case the rent is affordable for us. Let us see this. We'll first replace the rent by its value. So rent is $1,200 itself. We'll check the first particular condition, guys. Is 1,200 greater than 1,000, guys? Please do let me know. Is 1,200 greater than 1,000, guys? Of course, yes. We'll write true. In a similar manner, is 1,200 less than 2,000, guys? Of course, yes. Right? So this is also going to be true. So true and true. If on the AND gate or the AND logic itself, if both the sides are true, the answer is also going to be true for us. So according to our hypothesis, we should get a true answer, guys. So we should be getting a true answer right over here. If we run this by taking up the original question, as you're able to see, we are getting is affordable is true. We're getting is affordable is true, guys. Using these comparison and logical operators, you can create complex logical solutions to your questions. And that is the reason why understanding true, not, and false, or are very important for us, guys. Okay. For example, right over here as well, you are having the same question. Rent is greater than 1,000 and rent is less than 2,000. We already know the answer for this. We have seen it just 2 seconds ago. We already know the answer for this. The answer for this is true. The answer of this is true. What is not true, guys? What is not true? Could you guys please do let me know? What is not true, guys? Please let me know. False, right? So the answer should be false. Let us check that. Is affordable is false for us, right? In a similar manner, learn a little bit more right over here, guys. This is a very important topic and a very easy one as well in that. There's nothing too complicated about it. Okay. The next particular topic is our strengths. We'll stop right over here for today. I'm able to understand today we have covered a lot of topics and I want you guys to revise it properly. I don't want you to overburden you with different stuff itself. Okay, for those people who have missed out on their attendance, please make sure you're coming to the classes on time every single day. Otherwise, every time you will be missing out their attendance. And today, just to teach them a lesson, I'm not going to take up a secondary attendance. Okay, just to teach them a lesson. I'm not going to take up a secondary attendance. Tomorrow I will be taking up 2 attendances. Okay, just to teach them a little bit of lesson as well. Okay, so now that we have taken up the attendance as well as we have completed today's class, please do make sure that you guys are able to complete your revision of today's class properly. Okay, we're going to take up. And one more, just a particular help. I wanted a small help from you guys. Can you guys help me out with something? I wanted a small help from you guys. Can you guys help me out with something, guys? Please let me know. A very small help I require. If anybody from tomorrow's class onwards, if anybody asks you if the attendance is taken up, just say, I don't know what is attendance. Just say, yes, the attendance has been taken up, or just say, I don't know what is the attendance. I want them to suffer a little bit. I love seeing them suffer. Okay, because I want you guys to be able to ask your doubts and everything, and I am not able to see your doubts right over there due to these guys. So anytime anybody asks you in the live chat, is the attendance taken up, or when is the attendance going to happen, just say, what is attendance? I heard this word for the very first time. Even I'm going to say that. I've already taken up the attendance, or I don't know what is the attendance. I heard it for the very first time itself. How many attendance are there in today's class? 6 attendance were there. We have already filled all the 6 attendances itself. We don't know anything, right? Just try to like torture them a little bit. It will be a fun thing for us as well, right? We will have a personalized joke between us, right? Okay. So we are going to move further with our class from tomorrow onwards at the same time, guys. We'll meet in tomorrow's class and we'll continue with, from right over there. Of course, before leaving the class today, if it's possible, do like the video. And if you have not yet subscribed to the channel, do that. It will be great if you guys are able to do that. I'm still able to see almost 50% of you haven't still subscribed to the channel. Guys, it takes up a lot of efforts from our end because in the morning, I still have my job, right? I come back at 5:30 and I sit and create these classes for you guys. It takes a lot of efforts from my end as well. And to be able to do this for free, to be able to make sure that we're getting these certificates and everything, to be able to partner up with different companies, we need a little bit more assistance from you guys. So if it's possible, if it's not a big deal for you guys, just spend 1 minute of your time to subscribe to the channel. It will really mean a lot to us. Okay. Almost 50% of you, almost 1,000 of you have still not subscribed. That is the reason why I had to tell this openly. Okay, so thank you so much, guys. The attendance has already been taken up early on itself. If you have missed the attendance, please come to the class on time from tomorrow onwards. If you have missed one attendance, we'll still give you guys the certificate. So if you have missed one, then you are having still an opportunity to get the certificates. Come to the class on time, pay attention to the class, then only you will be able to get the certificates. So thank you so much, guys. We are not going to take up the second attendance just to make sure that people get agitated a little bit more. Thank you so much, guys. And we'll meet in our tomorrow's class and we'll continue from right over there. I love you guys. I had a great time with you guys, and I hope that you guys have learned something in today's class. Thank you so much, guys. Bye, guys. Bye. 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 Bye.